Hey everyone, and welcome to the Retro Channel, and today we're taking a look at a big old box of Commodore 64 stuff. A local viewer contacted me recently and asked if I could look at their C64C before they go plugging it in and trying to power it on, and they also had a couple of other boards and a couple of power supplies that they wanted to get checked out as well. So I was like, yeah, sure, I'll take a look. And what we have here are two 64Cs, a single shortboard, a couple of power supplies, one old, one modern, and there's also a little baggie full of capacitors because they wanted to get the caps replaced on this particular one, which is the one they're going to be using as a daily driver, I guess. We also have a nice looking video cable, and that is about it. So what I thought we'd do is start by checking out this single shortboard because it's not in a case, so it's easy to get access to. And then we'll come back, take a look at the power supplies, and if we get a chance, take a look at these two C64Cs. So here's our random shortboard, and to be honest, I already had a quick look at this because I wanted to check the resistance between the power rails and see what they look like. I don't know when this board was last powered on, so who knows what kind of state it's in, and the same goes for the other two machines. So rather than just plugging them into a power supply, I wanted to have a quick look. And the first thing I noticed on this was the resistance between ground and 5 volts was really low. It was like 10 ohms. And now it's 300. I'm sure it was 10 ohms before. Well, that's weird. I basically took this out, checked the resistance between that power rail, and it was like 10 ohms, and I thought, okay, I'll put it aside and we'll do a video on it, see what we can find. But now it's up at 300. How bizarre. I'm not super familiar with the shortboard, so I don't know what the expected value would be, but yeah, 300 seems okay. In fact, let me grab my shortboard system. We'll have a quick look at that. All right, here is my 64C. Let's just pop the screws out, take a look inside. And let's just see what kind of reading we get on this. I'll just use the user port. Aha, 10.8 ohms. So I'm not going crazy. Well, I guess it is possible to have such a low resistance on a working machine, because I know this thing definitely works. But why has it since changed on the other board? Just do the exact same test at the user port. Yeah, it's up at 300 and something. Like, it's changing, so it looks like it's just, you know, charging or discharging a capacitor. That's really strange. Ah, I must have bumped the power switch. So with the power switch off, we get 10.2 ohms. That's really odd. I'm guessing my machine does the same then. Oh, with the power switch on, it's actually 1.5K. So maybe that's still an issue somewhere? I don't know what to make of that. We might have a quick look at the schematics, see if we can work out why it does that. Better yet, let's take a look at BWAC's shortboard replica. So this is a project that he worked on last year, so it is basically a clone of the original shortboards, and I think he did a couple of videos on it. Yes, along with the other boards that he's reverse engineered. Oh, and Tommy from Arctic Retro also did a couple of videos on the same boards, so be sure to check out their channels. I'll put links in the video description. And of course, if you're interested in building one of these yourself, there is the Gerbers available, which you can send over to our channel sponsor, PCBWay. Yep, PCBWay is your one-stop shop for PCB prototyping and assembly. They can also do CNC machining and 3D printing and a whole lot more. So all you need to do is grab the Gerbers from BWAC's GitHub page or anything else that you need built and send them over to PCBWay and they will handle the rest. We thank PCBWay for sponsoring this video. So BWAC's not only drawn up new schematics for this board, which I think fixes a couple of errors in Commodore's original schematics, but what's really handy is the interactive bill of materials. This is a really handy way to view all the nets that are on this board, or all the connections between components, and you can also view the actual components themselves in a list like this. So it's really easy to narrow down everything that you're looking for. What we're really interested in is what happens on this 5 volt rail. So let me select that and we'll just expand this a little bit. And I'm mostly just interested in the top side because that's where all our components are. What I want to see is if there's something on the 5-volt rail that causes that low resistance when the power is switched on. So looking at the switch, we can see the 5 volts comes out of the switch on the middle pin and then heads off over to all the components on the board. And I think this side, so it goes through this inductor here, and if we look at the other side, yeah, you can see that comes from the power connector. So that's our 5 volts coming in from the power supply, heads through the inductor to this pad on the switch. So when the switch is closed, it's going to connect this left pad to the middle pad and allow 5 volts to get to the rest of the board. And when the switch is open, it's going to be these two pads connected. And I'm seeing there is a resistor here at R19. What's a bet that that's possibly 10 ohms? Let's have a look at the component view. If we click on that, there it is, 10 ohms. Right, that makes a lot more sense. So with the switch off, we just have 10 ohm resistance to ground. So I guess they just put a resistor in just to keep everything at ground potential when the machine's powered off. So that at least solves that mystery. I still don't know why we're only seeing 300 ohms on this board when it's switched on and 1.5k on my board, but I guess we'll find out if we hook up some power to it. Something will probably start getting pretty hot. So that gives us the opportunity to check out these power supplies. Where did I put them? So what we have is an original Commodore brick. These seem to be the ones that shipped with all 64Cs in Australia. So yeah, this could be a bit iffy. And we also have one of the Electroware power supplies. This is like a modern replacement. So what I want to do is test both of these under load before I actually go plugging them into a machine. You could test them without a load, so basically just probing the pins for 5 volts DC and 9 volts AC. But without a load on them, you're not going to get accurate results. So what I actually did was built up this little thing the other day, and it's pretty much just a bunch of random parts that I had laying around, all soldered onto a spare bit of perf board. So it basically puts a 1 amp load on both the DC and the AC side, and then we can just measure that directly from this board. So I put a little meter on here that I had laying around so we can see the voltage on the DC side, and then I can just measure the AC side with the multimeter just across this resistor. So let's start off with the original Commodore brick. Hopefully it doesn't explode the moment I plug it in, but we're about to find out. Okay, no smoke, no fire. Let's plug it into my little janky board here. And we're getting a big fat lot of nothing on this meter. Let's check across the AC side. All right, we do see 9.8 volts AC across that resistor. We should see about 5 volts across this one. We're seeing stuff all. And yes, this is probably already quite warm. It's like a little hand warmer at the moment. Now I'm wondering if I got the DC side wiring correct on my board. So on these power supplies, you've always got ground on the middle pin, and then 5 volts can either be on the right hand pin or the left hand pin. As you can see, Commodore pretty much removed all the excess pins that were on this connector and just left the 2 AC and the 2 DC pins. And I briefly tested out my board and it seemed to work with another power supply, but perhaps it had the 5 volts on the left hand side of that pin and not the right. And in fact, we can see that here. So I connected the left-hand pin to my little voltmeter and to that resistor, and on this one, it's the right-hand pin that needs to be connected. So I'm just going to connect both of those together. All right, that should do, and yes, as the name suggests, this is very messy. I pretty much used random offcuts of wire that I had laying around just because I didn't want a voltage drop across these wires affecting the measurements that we'd be taking. So I am using some illegal wire colors here, but it's not designed to be used by anyone else except for me, so it's perfectly fine. Let's plug this in again, and we should see our meter light up. There it is, a nice solid 5 volts. The current meter isn't working properly. It was working before I built this thing when I was testing it out, but once I soldered everything together, it stopped working. So I think I might have broken something there. Maybe there's a little fuse that I blew on it, but it's not really necessary. We have our voltage rating and we know that it's going through 4.7 ohms resistance, so we can work out the current using Ohm's law. And yes, they do get toasty rather quick. They pretty much are dissipating the 10 watts across each of them. So it's almost like a little heater board. What it does tell us, however, is the original Commodore brick should be safe to use. Let's test out this modern replacement. Let's see what results we get from this thing. 4.7 volts, 4.8. So I'm guessing there's a bit of voltage being lost across this cable. Oh, 4.9. Could be just my janky board as well. That seems okay. It should still reliably run a Commodore 64. Let's have a look at the AC side. And yeah, across the AC we're seeing 9.7 volts. That's perfectly fine. Good enough. Alright, well I'm satisfied that both these power supplies should be safe to use. So let's just hook up this board, see what happens. I'm just going to use my video cable for now. We'll check out the other one soon enough. Alright, will we get any signs of life? Huh, it works. It just works. Of course it does. These boards are generally pretty reliable. Sometimes you might have bad RAM or a bad CIA, but the Super PLA that's used on these boards is reliable, as is most of the other stuff. So it's rare that I see a fault with one of these boards, and that's probably why I only have one shortboard, because I'm generally fixing these things, and it's the long boards that I get more often because they're the ones that have issues. I might just quickly go over these contacts just to clean them up a little bit, and then we'll hook up the diagnostic harness just to make sure there's no other faults here. And then a little bit of contact cleaner in the other ports. Alright, diagnostic harness is hooked up. Let's see what we get. Ew. Well, that's not good. Everything's seated properly. Try again. Yeah, okay. That's not great. I don't know whether to believe those bads at U9, U11 and U22. Obviously that's pointing out the original 8 RAM chips that you'd normally have. The shortboards only have the 2. Let me just disconnect the harness. We'll just try and run the diagnostic without it. Oh. Now it seems to be running. Timers look good. I don't have sound connected, so we're not going to get any sound, but all those bads are pretty much because we don't have the harness connected. So let's start by just hooking up a couple of bits at a time. See if something here is causing that issue. Alright, that seems to have started. Let's hook up the keyboard. Still going. Joystick ports. Still good. So the only thing left is the serial loop back. And now it's working. This is exactly the same as how I had it set up when we first tried it. Just going to power cycle it a few times, see what happens. It seems happy. Let's see if it passes all the tests. All looks good. Really should have hooked up sound. Well, I only caught the end of that, but the SID is making sound. I don't know if it's fully functional, but it appears to at least partially work, so that's good. Where's that other video cable? So here's the other video cable. It looks like it was made by Retro Computer Shack, which I've heard makes good quality cables, and yeah, it looks pretty decent. Let's open it up, test it out. All right, there we go, all hooked up. So that's composite, which looks pretty decent. And if we go over to S video, yeah, it's pretty much how it looked with my cable as well. Will we get sound? Yeah, the sound sounds good sounding. So it seems to be a fully functional board. Obviously the SID may have other issues, but they won't be revealed with that simple sound test on the diagnostic. But I'm not going to bother looking at that right now. I'll do a proper test of it later on. I doubt there's going to be any issues. As I said, these shortboards are pretty reliable. So we did have a random issue when I first hooked up the diagnostic harness, but maybe that was just a poor connection somewhere causing that. But yeah, this board seems to be fully functional. Just needs a bit of a clean. Okay, I just took a short break just to recharge my batteries, including this one, and I saw another video from Noel's Retro Lab. He's actually put out a couple of videos so far on his second channel, and he just released another one on Patreon about this particular power supply, well, at least the Electroware branded power supplies. And I wanted to take a look inside this one because a couple of things that he showed in the most recent video are a little bit disturbing. I won't share it because it's only available to his patrons at the moment, but probably by the time my video goes public, his video will also be public. It's just the way a lot of creators work. Patrons normally get early access. Anyway, that's not what I wanted to talk about. I wanted to see what's going on inside this thing, and I'll put up a little screenshot of what he showed in his most recent video. And as you can see, the PCB in that power supply is somewhat bowed, and that's kind of a bit of a worry. So I wanted to see if this one here is the same. I think his is an earlier model. I think they did revise their power supplies at some point, so maybe they fixed it with this one, but I want to check that out because I don't really want to say this power supply is good and then it breaks, 6 months down the line. So let's take a look on the inside. Interesting little arrangement with the feet. So I'm guessing it'll just open. Yes. Okay, this one does look slightly different. The transformer is a different color. If we look at the edge here, you can see this board is also bowed. So yeah, that's a bit how you doing. Now there are little bits of hot glue, I guess, just to keep everything in place, but I do want to have a look at the underside of this connector here, so I need to get those screws out. I can always replace the hot glue afterwards, I guess. So I'm just going to spray a little bit of IPA on the hot glue. That usually helps to just break it free. If my pump bottle would work. Alright, and now we should be able to remove these screws and take this board out. Right, well the solder joints don't appear to have cracked or anything, so I guess that's a good start. So it does look very similar on the underside. I think the only thing I see that's different is obviously, this transformer. Perhaps it's slightly different for the Australian market because we usually have 240 volts here. And there's also this capacitor up the edge here, which is a 470 microfarad 25 volt, which I'm pretty sure isn't on Noel's power supply. So I'm guessing that's sitting across the 5 volt rail. And maybe that's there so that when you power on the 64 and it draws a bunch of current, this power supply doesn't go into overcurrent mode and shut down. So there's a bit of a reservoir here. Perhaps that's the one thing that Noel's power supply really needs. I don't know, to be honest. I'm obviously not the maker of these things, but yeah, that is kind of interesting. But yeah, apart from that, it seems very similar. I'm not a big fan of how this board sits when it's actually in the case though. And even some of these screw holes have a bit of an odd tolerance. So I have to wonder if Electroware is just buying a shell like this and then sticking their own PCB in, or if they had this custom made for this job. But either way, I think they should look at either using a different case for this or reworking their PCB to fit a little bit better. That's just my opinion though. So I think what I want to do to stop this board from flexing when it's screwed down is just to add a couple of little nylon washers to these screw holes. That should just provide a little bit more support and stop the board from being pushed down on the edges. So I'll pop this back out, and I think these little guys, if I could pick them up, should fit pretty nicely. Let's see how that goes. Okay, so even with those washers in place, it still bows down a little bit, so maybe that's just happened to the board over time. The other end, it's pretty secure. There is a little bit of flex up here, so would help to have, you know, a screw down this end somewhere, but I guess that's up to the people at Electroware to figure that out, not me. Alright, I've thrown a little bit of hot glue back on there, and I'm just going to close this lid, and it looks like they actually managed to trap this cable in top of the foam here, because there's nothing in the lid of this thing, so I'm just going to try and avoid doing the same thing. So I don't particularly want that cable just pressed up against the top of the lid. So it is what it is. I feel a little bit better now that I've looked inside. I did manage to get some IPA on the label by the looks of it, so yeah, sorry about that, but you know, it's a label, it's fine. You can still read it. I thought I'd just quickly check this out to see if it suffers the same issue that Noel was having with his, where it sort of delays the startup for a little bit. And yeah, this one doesn't seem to suffer the same issue. It's pretty much instant 5 volts, and there's no sort of hesitation or lumpiness. There is a little bit of a lump there, but bringing up the cursors shows that's only 300 microseconds. So certainly not the half second or so delay that Noel was having. So yeah, I don't know. Maybe it is that little capacitor on the output that makes the difference. Anyway, I think this power supply seems to be fine, and maybe we'll leave the 64Cs until next time when I'm not so hung up on checking new and old power supplies and weird resistances on boards that I don't understand. And yeah, we'll check the other ones out in the next video. So thank you all for watching. A huge thanks to the people that support the channel on Patreon. If you want to do the same, links to that are down in the video description. You'll get ad-free early access to all videos. But yeah, I think that is it for this time, and yeah, coming up sooner rather than later, we'll look at the other two 64Cs. So thanks for watching, bye. It's still good.